Hello everybody, welcome to your first official remote learning lesson here in Algebra 2. We are going to do a little bit of review this week, going back to information that was covered in geometry, but you may or may not have forgotten, is very useful when we study trigonometry here in Algebra 2. We are going to start with right triangles this week. So this is going to be your intro to right triangles and trig ratios. So as I go through this video, you guys are now all in Algebra 2 and you're getting older and you know who you are as students. One idea would be to get any sheet of paper you can and follow along with me as if you're taking notes in class. Another thing is just to sit and soak and see what you remember. But if it starts to get a little tough, I do suggest writing something down. Again, this is the way that I understand this concept. Recall that in your Khan Academy practice problems, there is also a beautifully typed out notes sheet that's exactly the same, and also a video in someone else's words and understanding for you to also access. So for the first thing, we need a right triangle. So what you basically need is a three-sided figure, quadrilateral, and you need that right angle. So as we go forward here in the next 3 weeks of our Algebra 2 trigonometry unit, we need to make sure that we understand some basics. Number one, if I'm going to give the angles some names, we typically use uppercase letters, usually A, B, C, but again, you can see anything, so be prepared for that. So there are my three angles. Angle B is my right angle, or my 90-degree angle, because it's got that little square marking there, which implies 90 degrees. Another thing we need to remember about a right triangle is that it has a lot of different pieces. So the first piece I want to talk about is the piece directly opposite of that right angle. The right angle almost points at it. Some of you refer to that as the slanty side. Fair enough. But this piece right here, if you remember, is going to be called our hypotenuse. Again, this is a review week. This is a how does it feel to learn on a video week. This is our hypotenuse. This hypotenuse is directly across from angle B. So I can actually refer to this as little b. Those are corresponding angles and sides. If I look at angle C for a second, if I'm looking at angle C, the piece opposite angle C is now going to be little c. And if you look at angle A, the piece opposite from angle A is going to be little a. So here's how we generally talk about any kind of a triangle, but this one in particular has an hypotenuse, and then these two are of course referred to as our legs of the right triangle. Okay, now we need to get a little bit more specific because we are going to start talking about trigonometry, and in trigonometry there is something called trig ratios. Now, trig ratios are a relationship between an angle, one of the angles in the triangle, and two of the sides. So there are three common trig ratios, and those three common trig ratios are sine, cosine, and tangent. And these are what we're going to be looking at today. So when we're talking about the sine of an angle, we are going to be talking about, if I'm looking at the sine of an angle, we need two sides that are going to create the sine of an angle. So for sine of an angle, we abbreviate looking like that. Sine of an angle, I'm going to pick something random like theta, Don't worry about that. It's just a variable used to describe an angle. So sine of an angle is going to be the ratio of the side opposite that angle divided by the hypotenuse of the triangle. So I'm going to stick with sine for a minute so that you can understand a little bit more about what's going on. So in our triangle up above, if I'm going to try to determine what is the sine of angle C, I'm going back up to angle C. I usually make a mark on angle C. I'm going to look at the opposite side, so that would be little c, divided by the hypotenuse, which would be little b. So sine of angle C is going to be little c divided by b. And there is your trig ratio. All right, let's move on to cosine for a minute. So cosine is going to be abbreviated as cos of our angle. Cosine is going to be the adjacent piece divided by the hypotenuse. I'm going to abbreviate it because I'm lazy. So if I'm looking at the cosine of angle C, we'll stick with C. So I'm looking up here. Here's the angle I'm focusing on. I'll make that highlighted. Here's my angle. Now I'm looking for my adjacent piece. Okay, so adjacent, if you have an adjacent locker with your best friend or an adjacent house with your best friend, your lockers are right next to each other. So if I'm looking at angle C, I'm looking for the side that is right next to angle C. Okay, wait a second, Miss Moore. We got two sides. Yeah. But one of them is already the hypotenuse. Hypotenuse always wins. So this piece can't be the hypotenuse and the adjacent piece. So my adjacent piece has to be side A. So I've got side A divided by that hypotenuse, which is B. All right, there's the cosine of C. Our very last one that we're going to look at is the tangent. So tangent is going to be abbreviated as tan of theta. Remember, you don't have to worry about that. I'm just going to write it out in case you can't understand me. Theta. It's just a Greek letter. We usually use Greek letters to represent angles. So tangent of theta is going to be the opposite piece divided by the adjacent piece. So tangent is our only trig ratio that does not involve the hypotenuse. So going back to stay consistent, let's look at the tangent of angle C. So I'm going back to that angle C. I'm looking for the opposite piece way across the triangle. There's little c. Divided by my adjacent piece. Remember, that is the piece right next to your angle. Can't be the hypotenuse. My adjacent piece is little a. So that would be how we would describe trig ratios looking at angle C. I'm going to do one more. Actually, before I do one more, I forgot the quick way to remember this. This is very wordy if you look at that. And most of you kind of remember that in order to remember sine, we're going to look at so. I write that maybe a little differently than your geometry teachers do, mainly because my kids can never remember which one goes on top. So if I write it like this, I remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent of an angle is going to be opposite over adjacent. So right there, that's where all the money is. So katoa. I'm sure you remember. Okay, so let's take a look at a random triangle. I'm going to draw it a little differently here. What if I draw it looking like this? Some kind of right triangle. And let's say I've got M and P and Q. I don't know. Here's my right angle. Let's say that this side is 5, and this side is 12, and this side is 13. Okay, so what if I want, you know, I'm going to do something a little fancy here because you guys are smart and you can handle it. I am going to look at angle M, but instead of calling it angle M, I'm going to use a fancy little Greek lowercase letter. It's an alpha. It's a lowercase Greek a. You don't need to know that, but you're going to see it again in some of your practice problems. So let's say we're looking at, let's do the sine of little alpha. Okay, so find little alpha. I usually like to kind of mark that angle. Highlighters are my favorite. So I'm going to mark that angle. Now remember, I'm thinking sine, so I'm thinking so. Going back up here, I'm looking for the opposite piece over the hypotenuse piece. So when I'm looking at angle M or little alpha, I'm looking for opposite, here's my opposite, way across the triangle, over my hypotenuse. Okay, wait a second. Hypotenuse, remember, the right angle always points at that hypotenuse. So there's my opposite piece, 12. There's my hypotenuse piece, 13. So the sine of that angle is 12 over 13. All right, let's try another one. What if I want, let's do the tangent of angle beta. Whoa, angle beta. There is no beta. Okay, I'll throw it in right there. Tangent of angle beta. Okay, before I do anything, I need to remember what tangent is. Tangent, opposite over adjacent. So I'm not looking at any hypotenuse. I can just ignore that 13. Okay, well, you only have two options now. It's either going to be 5 over 12 or 12 over 5. All right, so let's take a look at beta. I'm going to mark beta, my little highlighter. I'm looking for opposite first. So all the way opposite side of the room. There's my 5. And then adjacent, so right next to it, remember, can't be the hypotenuse. Right next to that angle is going to be the 12. Okay. So there you go. We're looking at sine, cosine, tangent for the acute angles in a triangle. Sine, cosine, and tangent for the 90 degree are a little different, so we're not going to reference those for now in your mathematical careers. Okay, that was 12 good minutes, almost 13, of math instruction. You guys did great. Why don't you take a look at the practice problems for this first section in your Khan Academy accounts, which are going to be the first practice set, 4 problems only, in trig ratios in right triangles. Thanks for listening. See you later.